Yes, I was here thinking deeply about the meaning of life. What are we here? And so deep thoughts that I have there. And yeah, but no way. Come on, let's go. We are here today to learn more about ROS2. So are you ready? I don't need this kind of energy here. I need to be up to speed, be powerful, because we are going to need this energy here today. So I hope that you are all energized, you are ready, because we are going to learn very, very interesting things, and we are going to practice a lot of ROS too. And the first thing that we are going to do is to start by sharing the project with you. Remember that how does it work, those live classes here? How it works is that I have prepared, previously to this class, I have prepared a notebook, simulation, code, and I have prepared all of this into what we call a ROSject. That's a ROS project. And this package, I'm going to share this package with you so you can follow the instructions that I'm going to give on the screen in a minute. So you will be following myself and also doing at the same time. For that, you need a web browser and, of course, the one that you are using for watching this video. So no problem at all. And then we are going to open this ROSject and go step by step on the ROSject. There is a chat on the side of the video that you can use for asking me questions. Okay, so I don't see people here writing, so I don't know if there is any problem, because this is not very usual. Usually there is a lot of information there, people saying hello. So please, if you have any message, so if you are there, just tell me that you are there so I can be sure that you are there and listening and following. So in any case, remember the chat is there for asking questions. Okay, so let's go. What else? What else do we have? Yeah, sharing the project. So for that, I'm going to share with you my screen, and you are going to see what it looks like is for the ROS Development Studio. Okay, so I see here Chin Mei is saying hello. Hello, Chin Mei. Okay, so this is working then. Great. That's strange, because usually there is a lot of people saying hello from whatever, hello from India, hello from the States, hello from Barcelona, whatever. Okay, Moshin here. Okay, I think that you are latecomers to the class. June also, Juan, hello. And very good. So let's go. Let me share with you my screen, and then you will see my screen on ROS DS. Johan from Belgium, also I can see here. Hello, Johan. Let me see. Let me share here. And Mirko, also hello. Mirko, how are you doing? And let's see. So too many screens here. So let me go here. Okay. So here. This is the ROS Development Studio. You should have a free account, and because you're going to need it. So what I'm going to do is, this is the ROSject for today. Is the one of the live class number 43. That is the one here. And what I'm going to do is to share this live class with you. So what I'm doing here is pressing this button, share, and get the link here. So I'm going to push this link into the chat of the video of the YouTube channel, and you are going to receive that. The only thing that you need to do is to click on the link. So by clicking on that link, you will get all the information that I have included inside this project that you are going to see in a minute what it contains. Okay, so let me first, I need to shorten this link because the link is very long, and then the chat in YouTube, it does something strange. So I use Bitly to create a shorter link. That's it. So I got it. Then I'm going now. You cannot see on my screen, but I'm going to the chat and I'm putting it here. So there it is. So you should see now on the screen the link of the Bitly, And then by clicking on that link, you will get a complete copy of my project. So let me see. I see that the network is doing something strange. I see we have full connectivity. So let me know in the chat if you are seeing something strange. Okay, so if you have received this link, then click on it, and then you will get directly a copy of this ROSject on your area inside the ROS Development Studio. Of course, you need to have an account, a free account on the ROS Development Studio in order to get it. If you don't have it, no problem, just create it, follow the instructions, everything is guided directly by clicking on that link. Then the thing that we are going to do, once you have that ROSject on your area, just press here on the Run on ROS DS. By clicking here, you are going to get the ROSject to start. So what we are going to get by starting the ROSject? Well, the following things. You can say no to the restore workspace, and then automatically you will get the notebook that I have included inside this ROSject opened for you. Let me close this, and also the bit.ly. You don't need it. So you should see this notebook here that, wait, oops, the mouse is doing something strange here. It's okay, got it. Great. So this is the notebook. We are going to see in a minute what it contains, but let me check first in the chat if there is any problem. I see that there are no problems. So I suspect that everybody is getting the project with all the content and you are ready to start. Yes? Questions? No? Error, kernel not found? Yeah, it sometimes happens this, just say without kernel and that's all. So it's a random error that we have there and we have to debug. This happened last week also in the last live class. And says no kernel for Python 2 is true. So just say run without the kernel. There is an option that says run without the kernel. We are not going to run any Python code from the notebook today. Okay, so let's go and let's start. What is this live class about? It is about how to use ROS2 messages. And what we are going to see is what is a ROS2 message, how can we manage the messages inside a ROS2 system, and also how to create a publisher about publishing ROS2 messages. So we are going to create ourselves a publisher and show the information that we want on that topic containing that message. And then finally, there is something else that it's a homework. That it's about how to create your own ROS2 messages. Because here today, we are going to use the ROS2 messages that are already existed and that are already created by the ROS creators, the Open Source Robotics Foundation. So they have created a set of basic ROS messages. And those are the ones that we are going to use. But then you have the chance to define your own message. Okay, let me just state that this notebook is a collaboration between the Construct and Acutronic Robotics. And we have been developing this notebook as well as the simulations. So thank you to Alberto for also creating this notebook, and to Alejandro from Acutronic Robotics for creating the simulation and some code of the Mara robot that we are going to use. And as I mentioned, this live class is provided as a ROSject. And if you want to create your own ROSject, I have included here some information that you can check later to create your own ROSject, and then you can share with your students, with your bosses, with your clients. So because it's very interesting, because you can launch, anybody can launch this ROSject, and then they will get the same exact behavior as the person who has created the ROSject. That's interesting. And that's what allows us to do this live class. So I was doing some time just to check that everybody's up to speed. I see no more comments on the chat, so let's continue. The first thing that we are going to do is to launch a robot simulation. So the robot simulation is of the Mara robot that you're going to see in a minute. Is this robot here, and is the robot created by Acutronic Robotics, and is the first robot that is running 100% on ROS2. And that's why we are going to use it here, and also because super nice robot. And the thing that we are going to do first is to launch the simulation of that robot so we can start working with the messages that this robot is publishing, read them, create new messages for the robot, etc., etc. So how do we do that? Well, let's launch the simulation. First, we need to open a shell here on Tools. You go to Tools and then select Shell. And then on this shell, we are going to copy those commands that are here. Basically, they are sourcing the ROS2 Crystal setup. Then we are sourcing our ROS2 workspace. That this ROS2 workspace, let me show you before we start. If you do an ls, you will see here that there is a ROS2 workspace already created. So that's our ROS2 Catkin workspace, let's say, for ROS2. Okay, so we are going to put our programs there. So we need to source it. Also, we are going to source Gazebo and set up some Gazebo variables about the models and plugins. And finally, we are going to launch Gazebo with a plugin for make it run with ROS2. So the simulation that we are going to launch here is a ROS2 simulation. Okay, it's not a ROS1 simulation. So everything that is publishing this simulation is based on ROS2. So that's a very ROS2 heavy class. Everything ROS2 here. So cool we are. So copy all those commands that are there and then paste it on the shell. And then by executing that, what is happening is that it has started a Gazebo program, a Gazebo simulation with an empty wall. Okay, so is this empty wall here? So how do we get this window here? We need to go to Tools and Gazebo. So let's go to Tools, then select Gazebo, and then you should see here the empty wall simulation. That's it. And then it says simulation running, check green, okay, and here is the empty wall. Great. Now, what we are going to do is to spawn the Mara robot in that empty wall. And for that, we need to set to launch those commands here. They have been already prepared by Acutronic guys. And so you don't need to understand how does it work here. Okay, today is not about Gazebo simulations, but about messages. So just copy and paste, and that's all. Where do we paste? We need a new shell because the other one is running the Gazebo. So open on Tools, Shell. And then I didn't copy. Let me go here. I selected but didn't copy. So Control C. And then we can go here and paste it here. So after all the commands are executed, we should see here the Mara robot appearing. You can see that it's appearing on my screen. Let me get closer. Let me get closer because my mouse is still this mouse. I don't like it. Here, yeah. I'm using the tripod today, so it's a little bit difficult. Okay, so I have here the Mara robot with a gripper in there. So we are on business. We can start doing some message stuff. So I hope that all of you have the Mara robot there because you have a copy of my own ROSject, the one of the ROS Developers Live class. So you should be able to do the exact things that I have done, and it should work in the exact way. That's super cool. That's super cool. So says here, Johan says okay. Johan says done. Let me know if you have any problem to that point, okay? Because we are going to need the simulation publishing, the topics, and the messages. So it's important that you have that simulation working. So I see no messages on the chat, so I hope that everything is running. Okay, so let's go. Now that we have the setup running, Now, let's start with what is the concept of a message. Well, a message is like a piece of paper that programs, ROS programs, are sharing between them. So imagine that you have a program that is, for example, computing the amount of people that is detecting on the camera in front of it, of the robot. So this node, this program, ROS program, is detecting that, is expert on that. Then it writes into a message that information, and then it makes available this information into a topic for any other program, any other ROS program that can need this information. For example, could be that in the robot, there is another program, another ROS program that is talking about, so is in charge of saying hello to the people. Okay, so then it needs this information, because if there is a person, then it will say hello. Otherwise, it will say no. So this first node that creates the message with the number of people and the coordinates, let's say, so it's providing this message to the second node. And maybe there is a third node there that is a program that is in charge to move the head towards the people. So that also needs this message, this information that is on that piece of paper, in order to know on which directions to move the head. So that's basically the message. It's just a piece of paper containing information that one node has created and that it wants to share with other nodes that may need that information. Here I have put an example of a message, and it's a message that is created by the robot on the jointer states. So this is a message that is showing all the names of the joints and then the current position and velocity that they do have. So as you can see here on the whole message. So this is a message of a topic, of a program, of a ROS2 program. So okay, so that's an example, but let's check by ourselves. So what is happening with this simulation of this robot that we have here? So first, let's do the following. Let's open a new shell. Okay, go to Tools and launch another shell. I'm going to put it smaller here. And then let's do a ROS topic list in ROS2. How it is, the command is there on the notebook. It's ROS2 space topic space list. Sorry, yeah, there is a problem here because it's not a problem. I mean, it's how it works. So we haven't sourced the ROS Crystal command, the setup bash of ROS Crystal. That's why the ROS2 command is not available. So we need to do a source of /opt/ROS/crystal/setup.bash. If you type that, then this is setting this console on ROS2 mode, let's say. Okay, so now ROS2 command is going to be found. And usually we used to put this source inside the bash RC file. We haven't put it yet. Maybe in the next days we are going to do it. I'm not sure, because it depends on other decisions on the platform. In any case, you need to know that, because you can have this problem in your own computer. So that's okay. So let's issue again the command of the ROS2 topic. So if you issue that, then you will get a list of all the topics that are published there by this robot. You can see here is the jointer states. That's the message that we saw. So that's the topic that is publishing the message that we saw here on the notebook before. So let's do a thing. For example, let's talk about the so there is for every topic of those that you can see here on this list, they are publishing a message, and then every topic it publishes on a certain type of message. It's a certain type. So every message is like the type is like the structure of the data that they are publishing. For example, in this one here, and of the joint states, that is the structure. As you can see, there is always a name of a field, a name, and then a value. Okay, so the value of this one, of header, is all this. Okay, so it's a name, then a value, then a name, then a value, that is all this, and then a name, and then a value. So that's like the structure. That's what we call the message type. And in ROS1, it was very easy to get what is the message type of a topic, just by doing ROS2, let's say the same thing, topic, info, and then the name of the topic. So let's put the one that we have here, TF_static, that we have on the example. So by doing this, the equivalent command to this in ROS1, we got the type of message that this topic, TF static, was publishing. But here we cannot get it in this way for some reason that I don't know yet, why this topic info is not providing us the type of message. We cannot get the type of message that that topic is getting. So there is a trick for doing this, and is issuing the pub message instead. So let's use ROS2 topic pub. Then let's write the type, the name of the topic, that is TF static. Then once you are at this position, you can press tab twice, tab. Then the system automatically will provide you with these options here to follow. And in one of those options, you can find the type of the message that is providing this. So now we know that this is the type of the message that this topic is publishing. Okay, so now we are building, okay? Here, first, we know that there is a topic that is publishing information in the form of a message. Now, we know a way of finding the type of message that the topic is publishing, is this trick here. Okay, so now we know. But now we want to know what is the actual structure of this message. So how do we know the fields of that message? Well, then for that, we have a command in ROS2 that is called ROS2 space MSG, message, show, and then the name of the message. You can directly copy here this and type Control-V, Control-C, and Control-C, Control-V, sorry. And then by doing this, then we get the structure of this message. So what does it say? It says TF message, it is composed by a field that is called transforms. And this field transform is an array, because of this, is an array of transforms stamp. Okay, so transforms stamp, it's another type of message. So it's kind of another type that is created. It has been created by ROS, by the ROS2 developers. Okay, so this is the name of the field, and this is the type of the message, of the structure message that is embedded in this field. For example, in this case, is the same as header here. So header, actually, it contains all this information inside it. That is another type. All this is another type. I don't remember exactly one. I think it's header with H, capital H. Header with capital H is the type that is like this. And then it's called, the field is called header in non-capital H. Then there is an array of strings that is called name. So let's do it. Let's do this example so you can understand better. So instead of using TF transform, let's see the effort, the joint states topic that is here. Okay, so how would you do that? How would you do that? You would do ROS2 topic pub, and then joint messages, joint the state, sorry, joint the state, and then tab. Then it's going to tell us, oh, the message that this topic is publishing is this one, sensor messages joint the state. Okay, so now we can close that command because we don't need it anymore. And then we can do a ROS2 MSG show, and then this type. Let's see this type. Okay, here we have. So as I mentioned, there is a field called header in non-capital that is of type header. Then there is a name field that is an array of strings. So this name, let me come here, is this name here. And this is the array of strings that are the names of the motors. And then there is another array composition with an array of floats and another of called velocity, effort, etc. So you can see here the structure of that message. Okay, so let me go to see if there is any question here. Here there is a comment from Moshin that says a lot of the things seem to be the same as ROS1, so that's good. Yes, that's very good. There is one thing that doesn't exist, that is ROScd. So it's a pain because you cannot do a ROScd and go to the package. So do a ROScd and then the name of the package, whatever. You cannot do this in ROS2. So it doesn't exist, a command ROS2 cd or something, doesn't exist. I hope that this will be solved. Well, anyway, so what we have here is we were on the ROS topic, ROS message show of the TF message here. And let me explain you something. Let me explain you something to understand better. Okay, so that's a detail, but you may need it at some time. So here, if we do, let me go back here on the message show here. Yes, and we get this. So you see that all the messages here, they do have one part of the name, then there is a slash, and then there is a second part of the name, okay? So what does it mean here? Well, what it means is that the name, the actual name of the message is this one, sorry, is this one. The second part after the slash, that's the name of the message actually. But what you have before the slash is the name of the package that is defining that message type. So at the end, we consider that the name of the message, the type of the message, sorry, is everything together because they are inseparable. So you can have this type also in another package. So then the total number will be different. Okay, so what does it mean here? It means in this TF, it means that we have a field named transforms that is an array of a message type called transform stamped that is defined inside a package that is called geometry message. Okay, so we can go, for example, to geometry messages. Let's do it. You have the command here on the notebook. So we cannot do a ROScd in order to go to the geometry messages directly. So we have to do it in the old-fashioned and good way of Linux, that is cd opt ROS Crystal share. You have the path there on the notebook, okay? Geometry underscore messages. And here, if you do an ls, you will see that there is a message directory. Then inside that message directory, if you do an ls of the MSG, you will see that there are a lot of different messages defined, but one of them is the transform stamp. Let me find it. Transform stamp, here it is. Okay, so this is the message that you have. And yeah, so that's it. So that's how basically how it is, and how you can find the structure, the files that are defined of a message, the fields that compose a message, a different message. So now let's go for publishing a message from a ROS node. So now we know that there are some nodes that are publishing or receiving messages that are published. So let's create, in our case, let's create a program that sends a message to move 3 joints of this robot at random positions. So let's do it, for example, that every 4 seconds, there will be sent a message to all the 3 joints at a random position for each one of those. Okay, let's create this package. Let me check if there is any question before we go into that. I see there are no questions. You have some seconds for asking a question while I'm drinking some water, sorry. And yes, that water was very nice. Then Mirko says that he had a problem with the net and he is here now. Great, Mirko. I hope that you can follow the instructions now. So we are going to start with the creation of the publisher. So we are going to create a publisher that is publishing the information of a message. Okay, so let's go into that. And let me see if there is any other question. No, everybody's okay. Yeah, great. Okay, let's go. Then the first thing we need to do is to create a package for storing this code. Then let's use the shell that we have already open, this one. And let's go to the ROS2 workspace, because we need to put our packages always inside a ROS2 workspace. So for that, you can do cd/home/user/ROS2_workspace, and then inside this source directory. Okay, so you need to put it there inside a source directory. Great. So that's our Karkin workspace. And now we need to create a package. So for creating a package here, let's use the ROS2 create package. ROS2, everything together. Then we have to specify that it's package, pkg, is the command. And then the action of that command is to create. Then the name of the package. Let's call it like this. move_Mara. Okay, move Mara. Mara is the robot that we have here. So let's call it move Mara. So it will be move_Mara. Please use this name, otherwise some things below will not work afterwards. So you need to, I always say the same things, but I think it's worth it. So you can change those names afterwards when you understand how everything integrates. But if you change now, then you will need to change some other things below, and you may forget, and it will not compile, etc. So let's do it. Okay, so actually the full command is here on the notebook, and you can just copy and paste because it makes no, it has no interest. Let me copy and paste here and just explain it quickly. So the build type is amend CMake because it's the type of building system that we are going to use. And then as dependencies, I have included 2 things. First is the ROS2 CPP library. And then the second is the, we cannot see it here very clear, but here, let me open, yeah, like now. Is the HRIM actuators rotary server messages. Okay, so what is that? Let me show you what is that, okay? So for that, I'm going to press enter here, so the package will be created. Okay, now if we do an ls, we can see here that our package move Mara is here, has been created. Great. Okay, so what is this dependency? Well, that's another ROS2 package that I have included. And why is that? Because we are going to send commands to the joins, and the joins are using this type, so a message that is being defined into this package. That's it. Okay, so how do we know that? How do I know before? Well, you can see here that there are some goal topics for controlling the joints of the robot. So those are all the joint topics. How do I know that? Well, we can do a ROS2 topic list, and then we'll get a list of all the topics. We have all of them. Let me put this, minimize that. Okay, so here there are many of them, but the ones that we are interested on are those that say goal. Okay, so these are the ones. ROS actuation, servo motor, a number, and then /goal. Okay, so what can I do here? Let me copy this. So you can do the trick that I did before. It's called ROS2 topic pub, then the name of that topic, and then do a tap. In order to get the type of message that this topic is receiving, you know, the type is here. It's goal rotary servo. And this message is defined inside the package that is called HRIM actuator rotary servo message. And that is the package that I have included as a dependency into the code of the package creator here at the beginning on this ROS package create message. So that is how I got this dependency, how I knew that that was a dependency in there. Okay, it makes sense, I hope. Okay, so yeah, well, whatever. And then what else? Oh, sorry, I already prepared this question for you, and then I have answered that. Okay, but there is another one. I put another one below. Okay, great. Yes. So here is the structure of the message that we have to send on that goal. So how would you find this structure? How would you find this structure? What is the command? This is my question. Please answer that on the chat. So what is the command that you have to issue in order to get this structure shown on the screen? Okay, so I'm waiting some seconds for you. So I see a new comment from Mom, maybe it's hi. Well, anyway, hi. So here your question for you again. So what is the command that you have to issue? Anybody knows the answer? Come on. You have been following, then you should be able to answer. It's very quick. It's very easy. Okay, let me tell somebody. So, Moshin. Okay, here we have the first answer from Johan that says ROS2 message show followed by the message name. Exactly, yes. Exactly, and what is the message name? Well, the message name is what I shown before on the screen. So it's that is correct, Johan. Is no, sorry, on the screen, on the shell here is this one. This is the type. Okay. Okay, one answer correct from Johan. Yeah, exactly. So if we do that, so we will do ROS2 message show, and then we paste this name. One space there. Then we should get that structure. Okay, so wait. Oh, okay. Yeah. So it says unknown package name. Okay. So that what does it mean? It means that this package, as I mentioned, this package is the one that should define the message. Okay, so it says that it's unknown. So this, I don't know which package are you talking about. So why is that? So let me show you why. That's interesting, because this could happen to you in the future. It's a very common error. So it's because of the following. Let's go to Tools and then IDE. Then by doing the IDE here, so let me close the notebook here. On the ROS2 workspace inside the source, so there is a set of packages here that are, those packages are related to the Mara simulation and to the HRIM. And one of those, I don't remember exactly where was it, in which directory. Let me check. Well, but anyway, one of those, it was defining the messages. Now I don't remember the rated. I don't know if it was here. Rotary servo. Yes, but okay, so I don't remember exactly where was it defined, but it's in this, on those, all those sets of packages, there is a description of the messages. Okay, so it's a package that is this package here, HRIM, that is defining the message goal rotary servo, and that has been compiled by me. So you already have this compilation on your system right now, but we haven't sourced it. So in the same sense that we have sourced it here for the OPT ROS Crystal, we need to source our Catkin workspace in order to have access to the packages that we are defining here in our own ROS2, that is here, ROS2 workspace. So we need to access there. So the solution is very simple. It's just to do a source of the, well, you can put this strange symbol. I don't know how to call it in English. And then ROS2, and it's install, and then setup .bash. By sourcing this, what we are making is making this shell aware of all the packages of the ROS2 packages that have been created inside this directory in the source. So now if we issue again our ROS2 message, now it's going to show the structure. Here it is. And you can see the structure as in the notebook in the same way. Okay, let me see if you are following or you have. Oh, machine, it says it is in the generated rotary servo. Yes, so there is the message is there. Okay, so it's there. Great. Anyway, so we have that message there, that is structure. That's how we got it. And then, well, I have another question here, but let's skip it. So now we are going to get, what we are going to do now is to create the software for the program for publishing into 3 different motors and at 3 different frames. So if you come here, so this is the message that we have to publish on each one of the joints. So this is the structure of the message that we have to publish. And what it does, it contains, well, basically it contains a header here, and then it contains a control type here, a position, a velocity, and an effort value. All those here in the middle, they are not part of the message itself. They are just definitions of values. Okay, so, and then this is used, this definition value is used here for the control type. So the control type field has to contain one of those different control types. In this case, we are going to use the position, okay, the control type position. So control type in all the messages that we are going to generate are going to contain a 1. They are going to contain a 1. So another thing that we need is to understand what is the header field. What is its structure here? So for that, we need to get into, again, into the shell and do a ROS2 message show of the, I don't remember exactly, it's, okay, it's HRIM generic messages header. Okay. And then inside here, we have that this header is made of two things. First is a field called stem that is of type time. And then there is a frame ID that is a string. The frame ID is the frame in ROS, so the frame, the reference frame from which the data is being measured. So for each joint, it will have its own frame ID. So this is something that we need to find. So which ones are the frames for the different joints? So for that, let's do one thing. Let's launch the RBIS, the tool of ROS that allows us to see the status of the robot. Let's open RBIS for ROS2, and then let's check the different frames that we have there. In order to open RBIS, you only have to go to a shell and type RBIS2, and then launch it. Then the RBIS is going to open, but because it is a new window that is not a web application, so we need to, in order to see the output of this, the new window output, we need to go here to Tools, and then open the graphical tools. Okay, so by opening this, we'll get here the RBIS. Here it is. Then in order to be able to see the configuration that you have here in this screenshot that I have put it here, I have included into the code in this package a config file. So let me put this into the whole size. Then you can go to File here inside RBIS. You can go to File and then say Open Config. Then here you have to select, go up one directory, then select the ROS2. Sorry, no, it's here. It's directly here. Just one up, and then just get the config RBIS. This is a configuration that I have created myself. And then here you have, by opening it, you have here the whole structure of the frames of the Mara robot in RBIS, and also with the links of the frames. So we are going to move the link 1, 2, and 3, for example. Okay, so those are the frames that we need to put into the message. It's motor1_link, motor2_link, and motor3_link. So we need to specify the frame ID for each message that we are sending. It means, A, whoever who is taking this into account, remember that this information that I'm sending you is reference to that specific frame ID. Okay, so that's what we get. Okay, so we got RBIS running there for ROS2 also. You can minimize this, we don't need it. And now let's go and write the publisher here. So here we have the code of the publisher. And for that, we can go to the IDE. If you open the IDE again, for opening the IDE, you go to Tools and then select IDE. That's it. Let me check if there is any question. No questions? Okay. So here we have, inside the ROS2 workspace, we have, let me close some of those package directories because it's a little bit confusing. So we have here the Move Mara directory package that we created. So let's open it and go to the source and do a right-click, new file. Okay, and this new file is going to be called Mara_publisher.cpp. And if you open that with double-click, then it will open on the side. So here, so you can copy directly all the code of this cell here. And I'm going to explain you, okay, step by step. So let's go up. You can do a Control A to select everything, then Control C and come here to the IDE and do a Control V. Great. Okay, so far so good. So we have the code here. I'm going to include here. Remember to save it with Control H or File, Save. Okay, so we got the code there. What is this code doing? Let me put it in bigger screen. Oh, okay. Here. So basically what this code is doing, apart from initializing the node here it's initializing the node, then we are creating 3 publishers, as we saw in the previous live class last week. So this publisher, in order to create a publisher, you have to follow this structure. Use the node, create publisher, and then here specify the package where the message has been created, then the directory, or is the workspace, but let's call directory, and then the name of the message. So we are doing a publisher. We are going to publish messages of this type called rotary servo that we have identified previously, and we are going to publish on the topics goals for those joins. So one is for the join 1, then another for the join 2, and another one for the join 3. Okay, so that's it. That's for creation the publisher for each one of the joins that we want to move. Then, okay, we create a loop rate here for 0.25. That means once every 4 seconds. So it's going to publish on those joins once for every 4 seconds. Then what else? Yeah, so we create a message. This is the message that we are going to fill with the required data in order to move the robot. So this message is of the type that we have indicated. It's an H-rim actuator rotary message, goal rotary servo. So that's it. This is how you create a message for publishing into a topic. Okay, so you make it share. It's a share pointer to that. And then you specify the package, the directory, and then the name of the message. Okay, so now we have a message that we can publish on those topics, but this message is empty. So all the values are 0 by default, or whatever the constructor has decided to make, but usually 0. So now we have to fill those information fields. And which fields do we have to fill? Which fields do we have to fill? Okay, so if we go here to the structure of the message, okay, instead of doing this one, let me go to the notebook that is, I think, is clearer. So if we have here, we need to fill the header, the control type, the position, and the velocity. The effort is not because we are going to control by position, so we can leave this part by default. But we need to specify a velocity for achieving the position. So, and all the joins are going to share the same velocity and the same control type, but not the same position. Okay, so let's go here again to the IDE. And what we do is that in that message, we specify the velocity as default for this value. It's just a value that works. You can play later. And then the control type to 1, that means position. Now, once we have that, then we start a while loop that is going to publish on those topics infinitely at a rate of once every 4 seconds. And the only thing that we do is to use the message that we have created to change the value of the position for a new random one. So we are using a random variable here that has been generated. And then we modify this position angle. It's an angle between 20 and minus 20 degrees. So basically, we are setting here the position to that value. And then we specify for which header frame ID. So in one case, it's for the motor 1. In another case, here, and then we publish on the joint publisher 1. Then on another case, here is for the motor 2 link. And then we publish on the second publisher. And then the same for the motor 3. So what we are doing here is creating a single message, but we change the values there every time that we are going to publish to one joint or another. That's the trick, okay? So that's as simple as this. Let me know if it is not simple for you and you have questions, okay? On the chat. So let's continue by now. So we need to create the launch file that allows us to launch this code. Remember to save, okay? So save it. Then in order to launch it, then we go to the Move Mara package and create a new folder that we call launch. Then inside that launch directory, create a new file that we are going to call move_mara.launch.py. So in ROS2, the launch file has to be a py file. Then open it and copy this code here. So this is a code, the standard generic code for launching a binary in ROS2. You just specify the package, then the executable, and then the output. Where are you going to? So remember to save this, Control S. And now what it remains is to compile the package. For that, we need to modify a little bit the CMake list. So let's open here the CMake list. And let's add this part that we have here in the notebook. So select that and copy here. You have to copy this here before the amen package sentence, okay? So press it here. And this part, what it's doing basically is to indicate that there is a new CPP code file that needs to be compiled. And it has to generate a binary called move_mara. Then it specifies the dependencies for it, and then how to install it. And where is the launch file also, how to install it. Okay, so basically that's it. It's as simple as that. You can use this for standard for your own packages and just modify the values there. Now we have everything ready for compilation, and then let's open the shell that we have already sourced with everything, the one that we have here. And okay, with RBS. So I'm going to close RBS because we don't need it anymore. It was just for checking the frames of the robot. So you can close it if it closes. Let me see here if there is the RBS already closed. Okay, so I'm going to close this window. Yeah, here it is. Core dump. Okay. Yeah, sometimes happens with RBS. And here we have the command that is using Colcon about how to build. So you can copy here. Yeah, remember that you need to go to the ROS2 workspace. So do a cd ROS2_workspace. Okay, so here, yes. And then do the command for compilation. And we are indicating specifically to compile only the Mara package. So it's only to compile the Mara package that we have created, so not anything else. So it's going to go faster. Okay, so it has finished. It should also have finished for you. And then the things that we need to do is, before we launch it, is to source again the ROS2 workspace. So in order to get all the new packages that have been compiled and installed. That is our move_mara, of course. And yeah, it's taking some while to finish. Actually, here it is. So let's do the source. And then the ROS2. You can copy directly from the notebook if you have it in front of you. Install setup.bash. That's it. And now we can launch it. Now that we have that, let me put here the simulation so we can see how it starts moving. And let's launch it. So ROS launch. No, sorry, it's ROS2 launch. Exactly, ROS2 launch. I was too fast moving. So forget here, ROS2 launch. And then the name of the package, that is called move Mara, and our launch file, that is move Mara, move underscore Mara launch.py. And okay, what's not found? Why not? Let me see. Let me see what is happening here. So it's not finding this. Let me see. Okay, let me check here. Is that correct? And yes, it is. It's there. And we have done the source. So yes. Oh no, it's there is something here wrong. Let me check. Here. Okay, so now it should work. Okay, so it says ROS2 launch, move, Mara. Let me see what I'm writing. Was not found in the shared directory, move Mara, which is at home. Yeah, so it should have been installed, but it has not been. Let me check here. It's correct. So this code is correct. Oh, okay, I see. I didn't save here. Let me save it. No, but it has compiled. So it should have been compiled correctly. So let me see what is happening here. It is on install Mara share. Then here it should be the Mara, the move Mara, correct. Okay, and then here, okay, so it doesn't show, then it has to be, it should be there, it should be here. Install directory launch destination. Let me check something that I'm missing here, but that is strange because it's been tested before. So maybe I have written something strange and something bad here, and I cannot see it now. Any suggestions, people from there? Yeah, mine is working. Yeah, Monash. Yeah, so it's how it has to be. So I don't know what I have done, because let me just compile it again. And let's see if it is working, because I cannot see the error. I think that everything is correct. So let's go back to the compilation directory and let's compile again. Move Mara, yes. And I have saved everything here. Yes. Any suggestion? Any comments? Is it working for you? Danny does is yes. Okay, says that all the people is reporting that it's working. Yeah, so maybe I didn't have it saved properly. I'm saying all the time that you have to save, and then maybe I didn't do it. So let me check it. But it's very strange because it did compile actually, but well, I don't know. So let me do a sort again. I'm doing correctly the sort. Yes, great. So let's launch. Okay, there it is. Yes, at some point I have made a mistake. So now it is moving. Yeah. So every 4 seconds is going to send a new position. Okay. Yes. Okay, so that's it. So you have understood how the messages work and how can you publish a message and how to fill it. Okay, so that was the goal of this. Then there is an extra goal that I have created for homework because that's too much for now. Okay, so the homework is about how to create your own messages. So we have been using some messages that somebody else has defined already. But imagine that you need to define one for you, for your robot, for storing information in this structure that you would like to have. Then here it is explained how to do it. So how to create a custom ROS2 message. So you have all the steps here. You have to follow those steps, okay? And then here you have some hints, some information about how to do some of those steps that have not been explained before, okay? Like modifying the CMake list, modifying the package, etc. So those are explained here in the notebook. So you can follow those instructions and compile your own ROS2 message. So here is the homework for you. So your homework is to create a custom message that is publishing the age of the robot. And then it has to say the years, the month, and the days since you have started your program. Okay, so you have to create a node that is publishing in a topic that is called /age. So you have to publish on that topic /age. You have to publish a message that is called age.msg. And this message contains this structure here: the years, the month, and the day since this program has started. You can put this inside the Move Mara package also, and as a second node to start. And then try to compile your own message and to publish in this way, and ask me your questions about the assignment in case that you are not able to do it or you have achieved it. Then do it and share it here in this link beneath the YouTube of this video, of this live class. So here is the link to this live class, the actual live class. And try to do it, because it's going to be a very good homework, a very good training for you in ROS2. Here you have some hints about how to do it, okay? And then before we finish and we go to some questions, let me tell you that we have an academy online that is called the Robot Ignite Academy, and we have launched it 2 weeks ago, a ROS2 full course where we teach all this that you have seen here and many, many other things about how to interface ROS1 programs with ROS2 nodes, how to debug ROS2 programs, about subscribers, listeners, services, etc., etc. So I have included here a discount coupon that is valid until tomorrow for 7%. You want to try. And also, finally, I have included here a link to the webpage of the creators of Acutronic, of the Mara robot, where you can pre-order this robot that you have in the simulation. So you can use it and in real life. So what you have learned here in a real Mara robot. Here you have the link in case that you're interested in buying it. Okay, so we have some time for questions. And let me share here. Let me go to the questions and see if you have any question there. How's it going, guys? Yes, did it work? Too much information? Or no, it's okay, isn't it? So maybe it's too much information now, just right now, that you have received everything within an hour. But if you review later, you will see that it's very clear. Remember that everything that I have explained is already included into the notebook. So you can follow step by step, or you can come later to the YouTube video and watch it again and do it in another condition, a second time. So any questions related to that? No questions. I see no questions. Jun Juan says it works for me. Johan works fine. Mohish, okay, recompiling. Danida says also, Johan, I'm new to ROS, but have been doing DDS before. I was surprised seeing that ROS identifies each joint with a separate topic. Well, I would have inspect key values in the message definition. Okay, yeah, so I have no idea about why they have done that in ROS2. In ROS1, we also do that. Let me think about, but I think that there is a way of using the controllers for setting up several joints at the same time. Yes, in ROS1. And here in ROS2, I don't know, remember that this is very, very new. So this stuff is the first, I would say that is the first simulation, gazebo simulation that is running 100% in ROS2 is one. So maybe we'll improve in the future. And also the real robot that is modeling this simulation is also the first real 100% robot that is running ROS2. So it's the first version. Maybe there is a better way of doing it in the future. I don't know. And then what else? No more questions? No more comments? Any suggestion? Okay, guys, it's already very late. Yes. And then we are going to finish here. So I think I'm going to keep thinking deeply about the life and what the implications, why we are here. I don't know, still don't have coffee. Okay, so I'm going to keep working on ROS2, I think. So see you guys on the next live class that is going to be also about ROS2. And remember one thing, keep pushing your ROS learning. Cheers.